Ugh, okay, there. Um, but it comes with this like PDF manual. Which, I guess we'll at least read through part of it or probably all of it. I don't know. I didn't really plan this out, so. But I think we read this thing before we actually get into the game. And I should have read this off stream, but uh, I sure didn't. So I won't do like that much, I guess. Okay, so starts off with this little note. M. We are all still in shock here from Uncle Randy's sudden passing. While we wait on word from the examiner about the cause, we are hoping as best we can. Coping as best we can. I've been occupying myself sorting through his things, especially his computers. Of course, I took one look in the garage, and it all looks like a bunch of junk to me. Send some pictures when I get a chance. For now, this machine that was set up on his workbench when he died. Maybe we'll be able to figure out what he was doing with it. He would like to know someone was going to finish his work. And Doris. Okay. The tessellated intelligence system is a massively parallel computer architecture. Shouldn't it just be massive? Why is it massively? Comprised of non-uniformly interconnected heterogeneous nodes. The tessellated intelligence system is ideal for applications requiring complex data stream processing, such as automated financial trading, bulk data collection, and civilian behavioral analysis. What was this dude up to? Notes like this one will appear in the manual to indicate scenarios requiring special attention and to refer to other documents that contain more information on the topic. System architecture and organization. The tessellated intelligence system consists of a large number of independent nodes connected on a local basis. I feel like I need some like background music. This isn't going to come through in the recording, but it feels like too quiet. Let's do this. Okay, cool. Node types can be broadly classified as processing or storage with several variants. Wait, number of independent nodes connected on a local basis. Node types can be broadly classified as processing or storage with several variants within each category. Generally, nodes are connected up to 4 neighbors via ports. Ports enable lightweight message passing communication between nodes. Communication over ports is coordinated by allowing either node to issue a read or a write to a port and blocking until the request is filled by the corresponding node. Okay, cool. Hard blocked first. You know what? We can say that you're first. If 2 nodes issue the same communication command, read or write. Dang right, we can't. He's also a liar. In Harlock, I'm not sure when that Phasmophobia update is coming out, but like, I'm down to play Phasmophobia like anytime, anywhere. So whenever you want, just like let me know. I guess connection between them. The nodes will deadlock and a hardware fault will occur. Refer to the separate document. How to use ports effectively and safely. Okay. Wait, do I have enough hard drive space to record? Okay, yeah, I do. I'm playing with fire with the amount of hard drive space that I have for recording, and I usually forget to check before I actually hit start recording. This document does not describe timing or throughput for no communication operations or instructions. These values may vary by model and hardware revision. Oh god. Are we gonna have to worry about like the actual hardware of this? Node type T20 reserved. Okay. Node type T21. Basic. How many pages is this? 14 pages? Oh my god. I should have planned this out better. I should have read through this before I started the stream. Okay. It looks like it's not going to be that like dense though, hopefully. The basic execution node is responsible for coordinating the behavior. Be delegated to a specialized processing or in storage nodes. The basic execution node executes a program specified in the basic execution node instruction set. The instructions short order. Yeah. I'm sure this would be a great thing to just not read instructions and start trying stuff. Execution automatically continues to the first instruction. Okay, so it loops. Communication ports comment to all the intelligence of the execution node that are used in the execution of this program. No additional memory is available. You only have your registers, okay. Additional is required. You need to use another basic execution node or a storage node, okay. Integer values are -999 to 999. Okay. So these are, I guess, our instructions? Or these are the registers? ACC's primary storage register for a basic execution node. So you use the implicit source or destination operand of many instructions, including arithmetic and conditionals. Okay. Back, internal non-addressable. Temporary storage for values in ACC through SAV and SWP cannot be read or written directly. Nil. Writing to nil has no effect. Nil means a destination operand to execute an instruction for its side effects only. Okay. Left, right, up, down. Port. Okay, so these are our 4 ports. Huh. Okay, and so not all ports are necessarily connected. Any pseudo port. The first value that becomes available on any port. Okay, so reading any value that's available. Last. The port last read or written using the any pseudo port. Okay. Okay, so here's our instructions. Source and destination instruction parameters may specify a port or internal register. Okay, any sort of port will block until the corresponding node connected to that port completes the communication by reading or writing a value. Source parameter may be literal integer. Huh, okay. BAK can always be specified as a source or destination. Oh no, why am I connecting to chat? Okay, well, it loaded now. Hopefully, if someone put a message in the last few minutes, I may have missed it, but... Label parameters are arbitrary textual names. Specify jump targets. Okay, good. So we don't have to do line numbers at least. Okay, comments. Use a pound. Double pound for title of the program? Hey, SPQ. It is displayed in the debugger to make browsing programs easier. Okay, cool. It's good to know. Label. Okay, so you would just write the text that you want with a colon. Is on a line with another instruction. Okay. Nope. It's the same thing as add nil. Nope is a pseudo instruction that has no effect on the node's internal state or communication ports. Nope is automatically converted to instruction add nil. I don't know why you would need that, but okay. Move source destination. So we can put 8 in the ACC register. You can move the data in the left port and write it to the right port. Data is read from the up port and then discarded. For fun, I guess. I'm sure that'll have the use, but I don't know what it is yet. SWP, oh, swap. The values of ACC and BAK are exchanged, okay. SAV. The value of ACC is written to be AK. Okay. Add source. The value of source is added to the value of ACC, and the result is stored to ACC. Okay. Sub. So same thing with subtraction. The value of ACC. Okay. Jump to label. Jez. Transfer execution conditionally. Transfer? What is... I don't know. I know what these three words mean individually. I don't know what they mean in combination. The instruction after the label will be executed next if the value of ACC is 0. Okay. I know what that means then. So if ACC has 0, that's basically like true, and it means you'll jump to the label and execute that instruction. If not, I assume you just proceed right after Jez. J and Z. That's the negation. Okay. Gonna run. So the actual game is here. I didn't realize the instruction manual would be so thorough. But if I create a new program, this is what it actually looks like. So I don't know how I'm going to actually do anything with this yet. It's basically used for memory alignment or to stall for time. Okay. So I'm a little concerned I'm not going to be able to do a single thing in this game, but I already hit go live, so I'm here now. J, if it's positive, okay, so greater than, less than. Are there crabs in this one too? Only if you program them, Dan, I think. JRO. Transfer execution unconditionally. Is that just a regular jump? The previous instruction will be executed next. Next instruction will be skipped. Okay, so if you jump 2, you skip one line and you execute the second line. Okay, they highlighted this one, so I guess jumping by ACC is going to be potentially important. Example programs. We're going to need this. The following sample, we're on page 10 out of 14. Okay, you know, sequence of values from the left port, doubling each value read and writing it to the right port. Because of the automatic looping behavior of the basic execution node, it continues to the first instruction of executing the last instruction. So we start moving, we read left, we put it into ACC, you add ACC to itself, which doubles it, and then we take ACC and we write it to the right port. This one reads sequence of values from the up port, writing positive values to the right port, negative values to the left port, 0 values are discarded. Okay. So we have a start label, then we read the up port, write it to ACC. If ACC is a positive number, we go to positive label, in which case we read ACC and write it to the right port, and then we go back to the start. Same with negative. And then if we get 0, we need to make sure that we jump back up to the start and we discard it. Okay. That's not so bad. Do I need to worry about T30? So wait, all that I just read it well was T21, I think? Okay, T21, basic execution node. What is T30 then? Okay, there's not gonna be that much more to read at least. So let's just read through all this. I really should have done this before I started, but that's life. The stack memory node enables read-write access to a large number of values according to a simple stack-based communication protocol. Okay, just a stack, I guess. Communication protocol. All interaction with the stack memory node is performed through ports. Find a stack of memory nodes, add the value to the top of the stack. So, what is that? First in, first out. If the stack is full, the right will block until space becomes available. Reading from the stack memory nodes, node removes the top value for first in, first out. What kind of stack reads and writes to the top? I forget how stacks are like works the way that I was taught. I thought you read from the bottom, usually. Or this would be called like a heap or something instead. The stack is reading from the stack memory nodes removes the top value from the stack and produces that value. If the stack is empty, the read will block until a value is available. Are typically connected to multiple other nodes, can be used by any connected node. Simultaneous reads and writes to secondary node are resolved in an undefined order. Each individual communication will behave according to the described communication protocol. Croc, I forget what kind of questions you typically ask if it's going to be super involved. If it's something that's relatively simple that I can talk you through, then sure, but today's just a game day for me, so. Like my next dedicated match would be tomorrow. Hey, Jed. Calculate a surface area? Like with an integral? Yeah, Jed, I didn't realize that I would have a 14-page manual to read before getting started, but I hit live before I knew that. It's Jed Banham with Trig. That sounds like it's going to be a little involved. If you want to post in my Discord, maybe someone will help you while I'm offline, or I'll get to you after I stream, but yeah, I'd rather just play my game for the stream today. T31 isn't available. Figure out who sold TIS-100 to swap meat dealer. Oh, swap meat dealer. Okay, I was like, who's getting swapped? But no, swap meat. Okay. Rebuild signal multipliers crossed out. Look for book of micro optimization tips. Review license plate or renew license plate tabs. Okay, I assume that's not relevant. So we have a debugger. We can do Control Z to undo, Control Y to redo, Control X to cut, C to copy, V to paste. Control arrow, navigate to adjacent execution node. View instruction set quick reference. Ooh. Wait. No, that is the wrong thing. Oh, okay, good. That'll be helpful. F2, view anti-tamper certification status. Begin running the current program, step or pause the current program. F1 for help. Oh god, dang it, Jed. Set a breakpoint, place an exclamation mark. Okay. I guarantee you I'm gonna forget that. Okay, this is the last page. Visualization module. Oh my god, you actually make images. Black, dark gray, bright gray, white, and red. That's a weird choice of colors, but okay. Visualization module resolution. 30 characters wide, 18 characters tall. The image console sandbox contains a larger visualization module that has 36. Draw a single... Wait, what? The top left corner. 0, isn't this not the top left? Isn't this 2 to the right of the top left pixel? Or I guess 2 down, depending on the order that... Zero. Oh, you're right, Phobos. Okay. Draw. Yeah, they say that they have a terminating negative value there with -1. Draw horizontal. You only have an hour. Croc, I'm sorry, but like I don't always do math help. Like I'm playing a game. I'm sorry, like uh but like not every time I do is math help, and it's only an hour. Like I'm sorry, but I'm gonna keep doing this. So horizontal red line in the top. So we start at 0, 0, and we keep putting in reds to the right. Okay, so we got to the end of the manual by some miracle. No, I don't. Is this what I actually have to start with, or do I assume I... Wait, self-test diagnostic. So... Okay, I guess I do just go to create new program. Okay, oh, here's what I do up here. Okay. Read a value in from in.x and write a value to out.x. Read a value from in.a and write a value to out.a. In.x? Oh, in.x is right here, and in.a is right here. And I assume these are stacks? What? Okay, wait. The left side are the test cases. Okay. Oh, so input and expected output, I guess. In.x is down this side. So am I actually being given in.x automatically? Like, oh yeah, so this is the port. Okay, so we move up to down. That's what this is doing by default. We have to get it to out. Oh. Wait, so this is already written for me on the left. I see. Okay, so we have in.x in the up port. We're writing it to the down port. It comes here. We read from the up port, move it to the down port, and then, okay, so that just passes it from top to bottom. Okay. And now they're giving us basically the same thing, but we have to, well, can we debug that? Oh, what the heck? Can't find a pen right now, so I'm just going to take notes here. Looks like short-term storage. Got this one at the swap meet today. Okay. I don't know what that... I don't know how that's debugging. I guess that's just like lore or something. So I want to move up to left. I want to move left down. Move up down. Move up right. Move left down. Wait. I don't know my left from my right. Yeah, Jed. Wait, I don't know how to spell right. I don't know my lefts from my rights, and I also can't spell right. Hey, okay. Wait, Jed, did you do this in 8? How is that possible? Or like 8 cycles? Node count. Oh, never mind. We're tied. Okay. That's the number of nodes you use, I guess. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now we go to signal amplifier. Read a value from n.a. I'm competing. Yeah, I guess so. Oh, you know what? Is this? I should maybe move my webcam to the bottom left, I guess. Okay. I think it's a better spot. Optimize your solutions? Apparently, yeah. Read a value from n.a, double the value. Write the value to out.a. Okay, they even showed us how to double a value. Yeah, Matthew, I was just thinking about how, like, you're showing me your assembly language stuff. It's like, ooh. This is my first time, like, I'm probably 5 minutes into playing this game. So we want to move up into ACC. So I'm still figuring out how this is going to work, but we want to add ACC, and then we want to move mock. We want to move ACC down, and we just bring it all the way to the output here. Move up, down. Move up, right. Move left, down. Let's run it. Assembly language game in assembly? TIS-100 okay. You prefer Shenzhen IO? Alright, so like that. I saw that was one of their earlier games. I don't know. This one just seemed kind of appealing to me though. Wait, you did it faster than I did, Jed? How did you get 84 cycles? I don't know how you would make this better. Apparently I do. Well, okay, this is like the quick. I mean, I assume I can't like put a label at the exit node and jump from this node to that label. That's not it. Gotta read the manual again. Oh god, now I put the manual over there. Give you, I mean, I guess it's not like that important, but like, what do you possibly do to make this better? I guess tell me. Parallel. Really? Okay, you know, that'd be cool to okay, well, I was wondering why we were given all these extra nodes, I guess. The first node is doing 3 things. So that's a bottleneck. Okay. True. How do I make it, like, maybe alternate nodes? Like, I would need it to, like, toggle back and forth. I mean, isn't that gonna... Okay, yeah, I think we can use jumps for that. So if we... Yeah, okay, yeah. I don't know why I'm saying yeah so much. But actually, what's in this debug thing? Okay, so get rid of all this garbage. Well, not all that garbage. So we can do we can make a down label. Well, okay, wait. Oh no, okay. We don't even need labels. Move up, down, and then move up, right. And then we can do move up to ACC, add ACC, move mov, not move, ACC down. Okay, and then we move left, ACC, add ACC, move ACC down. Move ACC down. I wonder if you can make it even better But like, I don't see how you use these two nodes over here or these two nodes over here, I guess. And I assume the order here doesn't matter. In this last node. Let's find out. The order, oh my god. How do I know which one is going to go first? It's going to move up to down first. This is going to... It's like the number of instructions, not the number of nodes. Use the step button? Okay. So yeah, we're first passing a value down. The 132 is already... Oh, one of those moving faster than the other? Hey, Pikachu. Oh, it's been a minute. Pikachu? How's it been? No? They're at the same speed. Why? Can I go back a step? No? Python to assembly language? I guess so. Wait, so what was the error? I should have been paying more attention. Move. Like, isn't it just going to sit in this port until I have an error in my code? I need to pay more. Okay. Pikachu, I'm getting values here, up here in .a, and I have to use assembly instructions to double these values and move them down here. I've already figured out like a basic way of doing it, but Jed's trying to like give me hints through to show a better way with like parallel processing. So each of these nodes are basically like their own CPUs, I guess, that are connected with like up, down, left, right ports. Look at what the next operation is. Well, I'm about to double 88 in this one. This one is moving... Oh, oh my god. I just don't know how to type. There we go. Hey, okay, there's my 84 cycles. Ooh, okay, we unlocked 3 at the same time. Differential converter. Read values from in.a and in.b. Write in.a minus in.b to out.p. The instructions are up here in the upper left, right? And okay, so they need to give each other their values. What's in the debug? Okay, so we have all these nodes on the left. So okay, if we want to do some parallel BRB, okay. If we want to do some like, can we start by instantly sending something down this left path and the path in the middle? Actually, yeah, so we can, well, no, I don't know if we can really, well, let's just write the basic version first without trying to get too fancy. We want to move up right so that the one on the right has it. And at the same time, this thing is going to move up left, so they have each other's numbers. Move up ACC. Move up. I assume the... Oh. Wait. Once I read it, it might go away. I think it does go away. Let's move up ACC. Move up ACC. Move ACC right. Move ACC left. Okay, so now they have each other's numbers. So in P, we want n.a minus n.b. So we already have n.a in the ACC. And we want subtract the source from... Okay, so they're each going to sub... this one's going to sub right. This one's going to sub left. And then we just move ACC on down. And I think this is like the basic version. Oh, well, that's actually not going to work how I hoped. Move up, down. So let's see if this basic way works. Why is it moving so slow? Is it blocked? What? Why is this blocking? Did I press the step? Did I? No? Both? Yeah, I guess. Yeah, no, so it's not stepping, it's just something's wrong with these ports. Both cores wait until the other reads the value. I think that's it. Will block indefinitely if a read or write command is issued. They do not proceed until they've gotten rid of their value if they're writing to a port. I think. Okay. And I never heard of that, but I guess I can accept that. So I guess we would fix it with a NOP? No? Nope, it's not nope. So what we need to do, they both write to the ACC on their first step. We want to first, I guess let's just take this entire line, do everything we need to do with that, and then we'll pass our value. No, but then we're messing up ACC. Bro, what the hell? I need... I need a swap. Well, no, no, I need salve. And then I swap. Okay. Download more registers? That's the real answer. Okay, so we're gonna move up into ACC. We're gonna save. That's what that stands for. We're gonna sub left. We're gonna move ACC down. We're gonna swap. Wait, really? Oh, it's SWP. SPP. That's clearly what I meant to write. It's working! Communication protocol for communication peripherals and a CPU on the same crystal. Oh. Okay. So, I mean, I assume these ports on the right are just not going to be helpful. Well... Ah, Jed did so much better than me. So, like, these ones on the left are going completely to waste. These ones, I don't know how we use them when that middle one is blocked. I did, but like you came up with a way better solution than I did. Um, is there? I mean, I don't see how we use. Maybe I do see. Do I see? No, because like I feel like we have to read the A's and B's in sync here. Otherwise, we're screwing up the stuff that we're subtracting. Unless I hand this left column a pair of A's and B's at the same time, and it does. Man, it's gonna be so hard to track though. This one, I might just let it be. You're encouraging me, Phobos? I don't know if I do got this. Looking up your solution. I think there's something that could maybe work. If I give this left column a pair of the values at the same time, it could do like A minus B in this one, send it to the right, and B minus A in this one, and send it to the right. But then these nodes need to distinguish between... Well, I guess they don't. Maybe they don't. What is the point of this? I have no idea, Hardlocked. I think the point is to suffer. There's some kind of lore behind it where like we found like there's a separate like PDF manual that comes with the game, and like this is the lore that they start you with, that your uncle died and your aunt doesn't know anything about the computer that your uncle had, and so you're apparently investigating to see what's up with it. And the uncle seems like he was already up to some shady stuff, like spying on people and stuff. So I don't know what's gonna happen. Oh, they're gonna be negatives of each other. Oh, true. So we could each of these three columns could have their own pair. As long as I handle it right, I guess. It's just the communication between the nodes is going to be the hard part. Um, yeah, we have the negation thing. That like we can use this thing to our advantage a lot. Alt F4, I like that command better. I assume so, Pikachu, yeah. Because like we could figure out A minus B, send it away, negate it, and send B minus A away. Um, but like, okay, say this node right here has a pair of A's and B's. It sends the first one down. Actually, maybe this communication isn't that... Okay, maybe... Let me cook. Move up left. On this, you're gonna move left ACC. You're gonna move up left. You're gonna move left right. Quick comment? Yeah, sure, Jed. Register files for casuals. What is that? Hardlocked? Hit escape. Okay. What's up? Are you just trying to gloat? I would respect. Oh, I shouldn't have deleted that. Baby. Oh, I thought that was some kind of code hard locked. Well, I already deleted it, unfortunately. You're right. I should have done that though. Can I? Oh wait, undo. No, undo isn't working. It's not undoing. Dang it. Okay. We didn't need that crappy solution anyway. It was taking up space. That valuable. That was like 10 bytes worth of data. You know, I need those bytes. Um. Sub right. Um. I'm gonna move ACC down. Oh my god. Because I want to do the actual subtraction here in this node. Or move up right. We should probably comment stuff, right? It's already getting that complex. A minus B. Move. No. Up ACC. Move ACC right. Move ACC down. B minus A. Move up ACC. Negate. Move ACC right. And this one over here, it's good. It just has to move up, down, and move left, right. Move left, down. That sends everything down. This one moves up, down, and it moves left, down. Without trying to think too hard about it. About like the sequencing. Okay, so we can test this and see if this runs. So it won't be optimal, but we can make sure that this part of it works, I guess. Because this should, in theory, do everything on its own, right? No? Yeah, we're already blocking. Wait, I don't know my lefts from my rights. That's a pretty big issue. Dude, it's so confusing. Wait, oh no, what the, who even wrote this upper left node, dude? Yeah, the top right. Thank you, Jed. Wait, is this not sub right? Why is this? Do I need to delay a cycle in this node, or why isn't this moving left? Yeah, I think I need to delay this a cycle. Is that what's the issue? Why, dude? You move left, right. Why isn't it moving left? Wait, oh my, fuck. Dude, the hardest part of this game is left and right. Move right, left. This is terrible, dude. Okay. Okay, so it's blocking, but that's okay because it's only blocking because it doesn't have an up value to read from in this node. Because I haven't programmed this up node here to actually do anything for itself. I'm glad I attracted at you. Me too, Jed. Okay. And you know, now I can write the exact same program that I just did in my initial thing. The path of in.b to out.n. In.b, move. Yeah, what's wrong with it? North, south. Wait, well, you still have to reverse it in each node, Phobos, I guess. I think I'm just stupid. It's the issue. Fault. Well, okay. My intention here. No, no, yeah, Jed. So I wanted to get this column to compute all the values, and now I want to do the same thing in this column and the same thing in this column, I guess. So I was just doing it one thing at a time. Actual assembly languages and some. I mean, I've written assembly code too. Um, it's so much easier when your registers are like absolute values and you don't have this like adjacent kind of construction, I guess. And you just have a register like address that you can always use. You don't have this like directional thing. At, um, but I don't know. Okay, so let's move up left, and then in this column we'll do another. Hopefully, just kind of duplicate this more or less. This ain't real program. Where's the JSON? Move right into. Well, we need to pull a value for ourselves, don't we? Move up ACC. Move right. No, we sub-right. Parse JSON with assembly language. Oh, wait. No. I wanted to have this column be its complete own thing, but this node isn't sophisticated enough. Or is it? As long as it alternates. Because I want to do both subtractions in this one node up here. And, well, do I have to do that? No, no, no. Okay. We can move up into ACC. We can negate it. No. We can move ACC down. We can negate it and move ACC right. We can move left down. Okay. B minus A. All right, see you, Pikachu. Thanks for hanging out. It's nice to see you again. Or just have you in chat anyway. Okay. Pass value left. Move up left. This is right. I don't know if this is even all that helpful. It feels cool though, right? Move left. Well, no, we want to move up into ACC. We want to sub left. And this is B minus A. Move ACC down. And that's fine to move up, or it would be fine to move up, down, but we need to store it for a second. Move ACC down. B, or A minus B. We're going to negate it. We're going to move ACC left. And we're going to move right down. Okay. Let's just pray this thing works. No! Not even one correct answer. This has gotten so complicated. Already. So our issue, we put a 4 where we wanted a 49. Oh wait, it's terribly out of sync. I think that's the issue, right? Okay, so this 44 and 93, it has to be the first one to go through. But I'm immediately sending it to the left. And I assume the values in this column are beating it to the punch. So I need to move, this left column is the first priority. The middle column is the second priority, and the third column is the third priority. So we need to have move left down be the first line in this program, so it blocks on that line. It's gonna error again, but let's just try this and see if we get farther. Okay, we got slightly farther. That 4 is still getting in there first, though. For N. So we need to prioritize moving left down in this third column. So it blocks on that, I guess. Now it's stuck. Because, okay. Ugh. I'm sure there's a way to make this work. Okay, wait, let's see exactly how it's paralyzed. So yeah, we've gotten our out.p. The out.n is the issue. So where is... our positive 49... Oh, okay, it's just this node at the end here needs to prioritize left. Okay, we got one step farther. Everything is blocked, just waiting for the port. How is this still on move left to down? Oh, because it just never got a left value in the first place. So I guess we need to switch. Does that go at the end? I'm doing this by trial and error. Ugh. Ugh. Okay, you know what? This isn't worth... I don't think this is worth it. This is a task for another time. I'm gonna make the code... I'm not gonna try to make each of these second two columns independently calculating things. Let's actually accomplish something today. This third column, it's working fine. We can well, let's just do things a little more inefficiently because it's not worth trying to optimize every single program every time. So we're moving right, left. Okay, and so we read in a new value, move up ACC, move ACC. No. No. Move up ACC, move ACC left. So pass the B value left before anything else. We need to store it though. or we need to put it, we need to save it. This is just trying to reconstruct the solution that I had right before this. In these two columns, basically. Sub right. We don't even need to save this, actually. We can do it a little bit differently. Sub right, move ACC down. Move up, down. Move ACC right. Move left, ACC, negate, move ACC down. They're trying to give each other values. Why? You're actually working on it now? Okay. You know what? Okay. Let's just not do this. Keep it simple, stupid. Save it. Swap it. Actually, I mean, I don't know. We still need to send the value over. And there's no point in making it do another subtraction. Okay. So put the up into ACC. Put the ACC to the left port. Dude! They're talking to each other, but they're not listening. Why isn't it blocking on this move left? I'm like, that's my intention. Move up into ACC. Sub right. Hey, Skirtle. God, you and your cute emotes. I wish I could draw. I'm just annoyed at my own lack of talent, I guess. What's happening? So we're moving ACC down. Want me to make you a cozy? I mean, you know, I would take it. I would want to pay you, I guess, but I don't know. Do whatever your heart desires, I guess. You have too much money? I mean, I feel bad though. You know, that's your like hard work there. $35 to your name is too much. I mean, 35 is a pretty big number, I guess. Ugh. Make them in a month or a year? Oh, all right. Well, thank you, Skirtle. If you don't, then I guess it's like no worries. But um, so it's saying it's moving up to the left. Why? Does this wait? Move up left. Move up left. Move right left. Move up left. Read. Yeah, wait, what the hell? Okay, now it's sending over the second value to the left, which is 60. I read it. Do I have too many? Oh, I just need to get rid of that third move up left. Is that the issue? There we go. No. I do have a, oh, you're right. I do have a cozy cat. In a cat blanket doing meth? Oh my god. You know, you can never have too many cozy emotes, or I guess too many meth emotes either. Honestly, yeah, I emotes are like I'm so terrible at coming with ideas for emotes. That little cat though does make me laugh with its little face. So this 27. Oh, can I just not think too hard and just switch these two lines? It is. It's just like something I found on Etsy though. A screenshot of my person? Oh, okay. Well, thank you, Skirtle. Um, why? Like, it's getting blocked down here for some reason. Let's put these back, I guess. At least gets farther in the program with this arrangement. So is this like a timing issue? Hmm. Scribble, this is it's a programming, like it's called assembly language, and it's like a really, why does it look like work? It is work basically. Yeah, it's a puzzle game. And it's messing my life up right now. Okay, this entire thing, it might be simpler if I mirror this code on the right side as well. Maybe. I don't know if it's actually going to be simpler or not, to be honest. Move up left. Move right left. That's still fine. But now we're going to move up right. We're going to read in a new one into ACC. We're going to sub left, which is B minus A. And we're going to move ACC down. We're going to move up into ACC. We're going to move ACC down. We're going to negate it, and then we're going to move it right or left. Same thing. What's the difference? I don't know. So then we can just simply move left, down, move right, down. A minus B. And I hope this is actually helpful. Does this work? Do these need to be in sync? Ah! Why? Why is this so hard to do? I could just throw this entire thing out with the left column and make my life simpler, but like I feel like this shouldn't be that hard. You didn't program a study program, you kind of do it for work. Oh, really? Like what kind of language? It's just out of sync. You finally optimized this one? I've optimized mine too. I haven't optimized it for success. Um, Set 1 has an odd number of inputs. Trying to do things in pairs will lead to deadlock. Really? Well, these have this, like, A and B have the same number of inputs, don't they? Or the entire thing is odd? I'm supposed to, but it's easy to do it yourself. Python and SQL for data science. Oh, cool. Am I wrong? Or like, I thought you worked at a daycare, or do you have a new job now? Either way, like those are like good things to know. Two n minus one values for n greater than 0. Okay, okay. I like what's happening right now is things are just like these are the right numbers, they're just not in the right order. Um and so it's like I'm doing the calculations right, it's just the synchronization that is really terrible. And if I switch the order, then I get deadlock. Two bachelors in fucking broadcasting and journalism. Only 10% of the work. Yeah. I mean, I majored in math, and the only job I could get was doing HR, basically. So I feel that. Okay, you know what? I, I I'm going back to my primitive thing that I did the first time, and I'm moving on to a different module. I hate this. This is too hard. The parallel programming. Um, it's too much for me, I guess. Subbright. You don't think you did it in parallel? Okay. That makes you feel a bit better. The BS Math Education, I was working at a temp agency, got a job doing data entry. Yeah. Also, hey, Obi. So, okay, I'm subtracting right. This is, what is this? It's A minus B. We're gonna... move ACC down. Send that one away. Move up, down. Move up, down. Got a bonus for making a computer do my job. Oh, hey! There you go. Two solutions, one optimize cycle count, the other optimize the node/instruction count. Time versus space. Fair. We're gonna negate... I mean, we can move ACC right and negate it over on the right, I guess. I don't think it matters all that much. Move right ACC. Left. Negate it. Move ACC down. Move up, down. Move up, down. Okay, get me out of this stupid thing. I'll try doing it another time. Save the channel. Yeah, burnt. Read a value from in, right 1 to out.g. Okay, so we're playing with ifs now. Yeah, it is, Obi. Block of static memory. Fuck you. They can't hide from me. You're doing that graph anywhere? Oh, do they have that in all their games? Okay. So we have one input here, 3 outputs there. So we're writing an absolute, we're basically counting the number of positive numbers, negative numbers, and zeros. Oh, yeah, good pin, Jed. Thank you. When a 1 is not written to an output, write a 0 instead. Okay, so I don't think... I assume there's not too much to do in the meantime in these nodes besides passing it down to the first output. Oh, move upright. So G wants, if it's greater than 0, so we need to get this thing into ACC so we can actually read it. Move left ACC. So we want to, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32 33 34 35 36 37 38 39 40 41 42 43 44 45 46 47 48 49 50 51 52 53 54 55 56 57 58 59 60 61 62 63 64 65 66 67 68 69 70 71 72 73 74 75 76 77 78 79 80 81 82 83 84 85 86 87 88 89 90 91 92 93 94 95 96 97 98 99 100 101 102 103 104 105 106 107 108 109 110 111 112 113 114 115 116 117 118 119 120 121 122 123 124 125 126 127 128 129 130 131 132 133 134 135 136 137 138 139 140 141 142 143 144 145 146 147 148 149 150 151 152 153 154 155 156 157 158 159 1, move 1 down. 0. Move 0 down. And now for, we want to, we want to JGZ1, but this isn't quite right. Am I an achievement hunter? Photographs are using space cam. Oh, okay. So yeah, but whenever I complete a level, you can see like Jed's stats because he's on my Steam friends list, but there's not like a global ones at least that I can find. Busy loop solve Seth. I mean, I'm not usually much of an achievement hunter, but what's this? Self-diagnostic in over 100,000 cycles. Oh no! Who's a filthy 100%er? It's me. I don't think I've gone out of my way to get all the achievements in a single game. Well, I know I've looked at the list for Factorio. I don't think I actually ever went and did it though. So a G gets a 1 if it's greater than 0. Or in any other, we always want, well, we want this to be exclusive. Okay. What's just the, we want a start. And we want, what's the universal jump? Jump, of course. Okay, so we're gonna JMP start. JMP start, and we need to put 2 more conditionals for Jez and Joel's 0, Joel's 0. And I think this is, yeah. Okay, I think that's the best we can do for that one. Oh, we do need to... No, is this gonna... No. I mean, it's gonna write 2 zeros, dude. No, it won't. Okay. But we also, before we do this, I guess we also need to move ACC right. Jump on imaginary 0. From scale, failed to score 100% achievements, you still feel pulled to try. I mean, there's some games that have hidden achievements, which are fun if you happen to get them, but will be terrible if you're trying to, like, grind all the achievements, I think. So, E gets JEL, gel. I wonder if that means something. This one is equal to 0. So we have a bit of a simpler condition that we can do. Illegal eagle. Oh, was there... Oh, find and solve... Oh! I wonder if that's JEL. It's an actual achievement in the game. That's kind of cool. So... 1... and none. If it's equal to 0, we go to 1. Oops. Is it JNZ for not 0? Yeah, JNZ. Well, we should really just call it 0. Just saying something about hidden levels. Yeah, but I mean the achievement itself is hidden, I guess. Like that one at least, it gives you a hint for where to start. So we don't need to pass this value along anymore. So this one gets negative numbers in L. So we're gonna say JLZ is 1 and JGZ is 0 and not have to think much harder, hopefully. Hey, let's go. Oh my god. Every time I'm gonna complete a level, Jed's gonna outdo me. But you know, it's my first pass. I just get through some also. I'm not gonna no, I'm not gonna unfriend you. I'm just making fun. Okay. Let's see what the debug is. I have an idea of where TIS-100 machine came from. Signal processing. The CIA cooked up to comb through Soviet radio signals. Hmm. Hmm. Okay. The lore. We got 3 inputs and a single output, so read values from n.a and n.b. Read a value from n.s. Ooh. Write n.a when s is -1. Write n.b when s is 1. Write n.a plus n.b when s is 0. Ooh, okay. Um, Interesting. Okay, so I don't know how this is going to work out. Like, we could probably send our values into this middle column and have this middle column handle everything, but I feel like we could have the left column handle writing A, the right column handle writing B, in the middle column doing their sum. The thing is, I'm gonna like this central thing is gonna get blocked though. Like there's a world where it just gets stuck if I do it like that, I guess. And so okay, no, I can't do what I was thinking. I wanted to like my first instruction in A be like move right nil just to make it block until we get to like a 1 in S, but we do, so we need to discard like this -13, I guess, because we start with a -1. So we always want to read all 3 of them in at the same time, I think. How are we going to communicate that stuff should be thrown out, though? Okay, let's maybe make this center column do the heavy lifting. Move up into ACC. That's probably a good first step. So we're going to say 1 -1, and 0 as our labels. If we have a 1, we're move up right, move up left. We always need to read from both of these ports in the middle, so we make sure we discard the values we don't want. If we have 1, we only want A. No, we only want... Oh, oops, I had that backwards. If we have negative, or if we have 1, we only want B. So we want to move left to nil. I think nil is what we want, right? Bring up the manual. Writing to nil is no effect. Good. Move right. We can do it directly like that. Move up, down, move up, down. We need to have a start label. Jump, start, jump, start, jump, start. Okay, so if we have... Actually, we can do the conditionals here. JGZ for 1, JLZ for -1, JEZ for 0. Good. -1 is just the value of A, so move left down. And now if we have 0, we do their sum. So move left ACC. Oh, we have a line limit. I thought it would scroll or something. No. Okay. Okay. Um, we need to put B down, I guess. So if we have, we want -1. If we're writing in dot A. This is gonna block though. What? How do we do this? Okay, maybe we do. Move up ACC. Move ACC left, move ACC right. And now each of these nodes is on their own to figure their lives out. Start move right ACC. Now A, we only want to test if it's +1, really. JMP start. Oh wait, move up nil, jump back to start. So if we have 1, we just throw it out. So we're gonna do JGL1. Wait, what? Sorry, JGZ. But if we aren't more than 1, what happens if we aren't more than 1? Move up, down, and jump to start? I don't have much of an end game here, though. So, like, we can... Dude, okay, so, like, my issue right now is... I'm properly throwing out A's input when we have -1. And I'm moving, and since in the scenario we do want A's input, I'm moving that input down. But I don't know how to distinguish between oh, you know, maybe this middle column can handle distinguishing between just A or doing A plus B. Something more than just throw out the input? There's probably a more efficient way than what I'm thinking, but I don't know what that more would be, because we're relying on B's input too, if it's anything more. What I'm thinking is we can move up right, and now this center node can handle either adding or throwing out the input we don't want. B can be nearly the same. JLZ -1. Move left. Could you replace it with something meaningful? Why would I want to replace it with something meaningful? We need to throw out A's input. Like, what would we ever do with A's input if it's +1, I guess? Well, I'm thinking the middle column now is going to... I'm passing the same -1, 0, 1 value down here. So I guess we're going to do our testing here? We need to either add them or not add them. Oh man, are we going to get blocked though? We're going to block. No, dude. Everything I do is gonna block. I am really close to very optimal. Really? Yeah, I guess you're right. But like what I was gonna do is move, up ACC. Oh wait, no, we can prevent it from blocking. Well, I mean, if I replace the input, then I feel like I'm going back to how I initially tried with writing everything in this one block. Like what identity? Like multiplying by whatever S is? Why what do we want to do with that? For the third case? Oh, passing along zero. Oh. Ha ha. So we always return the thing from this column and the thing from this column, or we always pass it along, but sometimes we'll intentionally pass along zero instead of nil. Okay, that's clever. Oh, frick. Oh my god, that. Zero. Dude, I can't. Wait, zero. Move. Wait. Oh, I moved zero into up. Dude, I'm getting so mixed up on this. Zero up. Okay. Oh my god. Down. You're right. Okay. What? Now, I don't need this. Move left ACC. Add right. Move ACC down. If B is negative, or did I mix up my condition here? If it's less than one, we go to none. If it's less than one, yeah, because B is positive one. That line's okay. All you've done is not read the input. You still have to eat the input. All you've done is not read the input. What? JGZ1, move zero down. Took out the move up nil. Yeah? Isn't that good? Oh. Never mind. Okay, you're right. God, okay. Dude, this is brutal. Go, okay. The jump start at the end. Oh, I guess so. Yeah, it's gonna do that automatically. Yeah. Okay. Ah. Oh, hey. Okay, so I'm equal to you now. Well, you did it in two less nodes. I guess I could have. Well. Oh, you took the values and put them back into this node, and then you put it down. Time versus. Okay, fair enough. Okay, let's look at the lore. New government encouraging me to get rid of the microcomputers I've accumulated over the years. Okay. No, you're good, Jed. Sequences are zero terminated. Read values from in.a and in.b. Write the lesser value to out. Write the greater value to out. Oh, okay, so do it in a sequence. Write 0 to end the sequence. Shut up. What? Okay, so I can immediately zips his lip. No, no. We're gonna need to have some kind of start, jump, start, and then like move 0 down or something like that. It might be better placed on the right column though. Write the lesser value to out, write the greater value to out. Write a 0 to end the sequence. Oh wait, we're writing a 0 every time. I thought it was only a 0 at the very end. Uh... So we're gonna need to subtract them from each other and see if it's positive or negative. And it's or equal to, it's the same number, so it doesn't matter what order things go in. They do usually give us an equal case as well. So just arbitrarily, let's just move up right, just to get something started. And let's do some comparison stuff here. Up ACC. Hmm. Wow. Okay, this is. It's so hard when you have a single. You really have two registers, I guess, to work with. We don't have very much storage space. So let's I guess sub left. Um, well, save it. Move ACC right. Um, how am I gonna do this? I'm doing B minus A right now. So if the result of B minus A is positive, we want to send B first, A second. Um, um, so where, like, the sequencing, like, we need to always send both of the values. We just need to figure out how we're going to do that. So okay, if I did another, if I just pushed another A value right, we can have this thing block until we want it in this column in the middle. And then this column in the middle can handle that sequencing. It's probably going to be way too many lines for this one node, though. So if this is greater than 0, JGZ, GZ. Well, we only need to test it once, I guess. Which, yeah, I mean, that's just what we're doing here. If it's greater than 0, we're sending B first. So we're going to swap, send, or move ACC down, move left down, move 0 down, move up, down, move up, down. Okay. Uh, and then in any other scenario, we send A first. So we're gonna move left down. In both cases, we want to swap. Well, E. Okay, we have to swap after we do this check, I guess. Move left down. Ah, that's not how you do a swap. Move left down. I mean, the swap can come after this. It'll make it a bit clearer. Move ACC down. Move 0 down. Jump, start, start. Exactly enough lines? No! I am exactly wrong. I did this comparison wrong. I'm moving up into ACC. I'm saving it. I'm subtracting left. If it's greater than 0, that means B is greater. I'm jumping down here. I'm swapping, which is where I saved B. Oh wait, it's lesser than greater. Oh my god. What? Okay. The lesser value first. Dude, I don't read the instructions before I do things. I messed up my copy paste. The code is good. Oh, I sure did. There we go. I'm sure there's a much better way to do this. Yeah, that would have been easier. uh, oh well. I got to an answer. All right. Sequences are zero terminated. Read a sequence from in. Write the sum to out.s. Write the length to out.l. Ooh. Okay. This wouldn't be that hard to do if uh I was able to use as many lines as I want. Let's look at the lore first. Okay. Let's just start writing some lines, I guess. Move up ACC. Start. So we want to check if it's 0. JEZ. Guess start can go first, can't it? JEZ 0. If it's not 0, then we'll do our business here with a jump start. If it is 0, we're going to move ACC down. We're going to swap. We're going to move ACC down. So I'm planning to keep the counter inside of the back register. Oh my, I forgot that any exists. Oh my god, that one other program could have been It wouldn't have blocked if I remember that you can use any as a port. Ah. Okay, too late now, but um okay, anyway, if it's not 0, we're gonna add ooh. We do not want to move up into ACC. Oh, how do we do this? Okay. I have 3 things I need to store. I need to store the number I just got. I need to store my running sum, and I need to store the length. So what we can do in like we can have this node on the right be our storage for length, I think. Um Okay, so we're taking. I'm going to assume that we already have our running sum stored in back. So we're moving up into ACC. Well, how does that work? Wow, this is already. If I want to, is there an easy way to add back and ACC? I don't think there is. You can only save and swap. Huh. Oops. Oops. So where am I gonna? So maybe I'm gonna keep my. Oh, maybe we're gonna keep our running total on the left here. Add right, and that's all it has to do, maybe? Well, it has to push its move ACC left, and this thing in the middle will throw out. If we get a 0, move left down. Move ACC left. Move. Well, we need to throw out. Well, this is waiting to get something on the right, so left nil. Just throw out the running total. Move right, or move 1 right. Add left. Move ACC left. Wait, Move ACC right. Move right nil. If it is 0, move left down, move right down. This is going to move up, down, move up, right. Move left down, move up, down, and move up, down. Is this a thing? No, it is not a thing. Let's step through it. So yeah, okay, we get a 35. 35 is not 0, so we move straight down. We're moving the 35 to the left. It gets added. We throw out the 35 input for now, because we're expecting another input. Move 1 to the right. It gets added. It's sending 1 to the left. We throw it out. We jump to the start. We get a 0. You see the issue? Ah. I'm never... This 35 isn't getting pushed. Okay. Same with the length. It's not getting pushed. Oh, you're right. I'm also not resetting the sub. That is an issue, isn't it, Jed? Interesting. Okay, so can we... Oh my god, how do we do that? Okay, so this thing, it needs to be smarter, unfortunately. You know, I also need to be smarter. Move right. No, I can't do it into ACC. If I swap, I can. Swap, move right, ACC. Well, okay, wait. Move right, ACC. JEZ0. If we get a 0, we're gonna do something, I'm sure. If we get 0... God, but I can't... I need to, like, have the input get pushed twice. Which, if this is smarter, I guess we can just do that. So I'm pushing our input once to test whether it's 0. If it's not 0, I read the input again. I want to swap it. I want to add right. And then I want to save it. If it's 0, I want to swap it, move ACC right. So my running total is being stored in back. I need to jump start. JMP. And the same principle can be applied here, I think. Move left ACC. Well, we don't need to push it twice. We only need to test it, and we already know it's going to be 1. So moving left into ACC. If that thing is 0, we jump down here and retrieve the total. And we're going to push it left instead. If it's not 0, we're going to retrieve the total, we're going to add 1, and we're going to save it. Dang it. We're not... Okay. We need to tell... If when we get a 0, we need to tell the others that it's 0. That's an important bit. Oh, bam! I feel like a 0 unlocked. Oh my god, I'm at like... You might say that I'm high percentile. I don't think it's a good thing here. I'm in the 99th percentile. I won't tell you if that's like better than 99% or in the 99% though. The upper end of the bell curve. Yeah, exactly. You may not like it, but this is what good programming looks like. I'm getting the high score. God, that was a crazy one. There's apparently a much better way to do it than I found, which is not surprising. Let's get our lore. You work too much already today? I get it, Jen. Yeah, if you program for a living, I can't imagine this can be that appealing. Gray hack? I haven't heard of that one. Okay. Um, read a value from in, compare value to the previous value. Write 1 if it changed by 10 or more. If not true, write 0 instead. The first output is always 0. Wow. So that's 10 up or down. Um, Now I noticed the only time they give us a 0 in these test cases is the very first one. So there probably is a little cheatsy way uh, to do that for 0. But I mean, I don't know if that's even the entire list. They might do more lists, I guess, that have zeros in them. Okay, so I assume we're gonna have this thing like move ACC left, move right ACC. Like this thing is just gonna be a storage for whatever the previous number was. In that first cycle, it's gonna default to 0 for ACC, and that's a probably a good thing. Probably. Um, so we're gonna move up left. We're gonna move, no, yes? Compare, okay, yeah, so we're gonna move up left. Are we? We would move up left. We would move up to ACC, I guess. So we're gonna have a 0 over here and then a 32 over here on this first cycle. Which that would get a 1 if I... Okay, no. Well, we want to start with moving up into ACC. And then we want to subtract left. And we want to say, I guess we'll do a label for true. Oh wait, we want to subtract left, but we need to see if it's more than 10. If that difference is more than 10, subtract left. I for like an hour. I still... I don't know what I'm doing either, to be fair, hard lucked. Yeah, I don't know what the point of the game is other than it's like going with it and uncovering the lore as you go, I guess. Story of my life, yeah. Okay, so if we have two positive numbers, uh, we're changing by 10 or more. So if we just keep our lives simple and we have two positive numbers, we would want to write a 1 because we can only compare with 0. So we need to subtract off another 9? I'm only thinking about positive numbers for now because I don't know how the hell you deal with negative numbers. Central 194th? Skate? It's my first time playing it. It's a cool game so far. I'm not too deep into it. It's already messing with my mind. Too deep, yeah. I'm never too deep. Just impossible. Um, okay, so if we have like 1 and 11, we're going to subtract them from each other and get 10. We would want to write a 1 in that situation. But we have to compare with 0, so we have to subtract off another 9, and we would get 0. So I think the sub 9 is good for two positive numbers. Like, we can even test this. Like, our test cases, they start off with only positives, so maybe let's write a program that works for positive numbers. JGZ true. Start. Jump start. Uh, we need to save this number for next time. We're gonna move a 1 down. We're gonna swap. We're gonna move ACC right. We're gonna if it's wait. We move a 0 down in this case. Move up, down. Move up, down. Now in this case it is true, so we're gonna move a 1 down. And then we're gonna swap and move ACC right again? This is I don't know what it's gonna do anymore. No, it doesn't even work on the first cycle. 1 to the left, 1 to the right, 1 up this time. Bang. Right foot, let's stomp. Left foot, let's stomp. Hands on your knees, hands on your knees. Bang, bang, bang. Yeah, I got this game on sale. I think sale's over by now, but it was just on sale like a week or two ago. Okay, well, we need to step through this thing and figure out why it's not working even for positive numbers. It is over now? Okay. So, why is this not moving ACC? Oh my. It's not moving ACC to the left for a very good reason. It needs to move ACC to the right. Price history? Oh, okay, nice. Now why... Oh my god. I swear, dude, the lefts and rights are the hardest part of this game. And the game is already pretty freaking hard. The UI is a lot prettier. Honestly, I kind of like this. Yeah, they are unlocked. Move 0 down. Why are you stuck? Oh. Okay, so I thought the output was right here. This time, it's not me being that stupid. It's my mic blocks the lowest part of my monitor, so I can't actually see. Oh god, I just hit something terrible. I'm good. I couldn't actually see where the output is. Okay. Okay, good. So this program works. For increasing positive numbers, I guess. I actually we get lucky. We just got lucky, I think. Well, no, it does work for 0 to 32. It doesn't work for negative numbers, and it doesn't work for a big positive minus or a little positive minus a big negative. Or negative numbers break it. Yeah, Jed, that's the issue, I guess. I could. JLZ to a neg. Yeah, I mean, I guess we want to do that in another node. So how would the absolute value work here? We top left or right node? Yeah, like in this node over here. I'll just point at it. 7,000% in a long time. They let you change the center dot on your screen? I did not know that, no. Wait, I don't know that. When you hover action, oh, cool. Now, why would I do absolute value here? So wait, we want like, if you subtract two numbers, that is always the distance between those two numbers. Right? We don't have to think any harder about that. Like, okay, yes, that's right. So all we want to do is take a positive and keep it positive after we do this sub left, sub 9. We want to take a positive and keep it positive. We want to take a negative and make it positive. And I think we're in business. But we're running out of room. So I'm probably going to take this code and stick it somewhere else. Actually, let's just put it over there for now. What? Where did this T go? Oh, it went there. It's probably bad what I just did, but I did it. Move ACC right. Move ACC right. Swap. Move ACC left. And now over on the right, we'll move left to ACC. And now we absolute value this thing. Glad the language decoding are a bit more accessible. Yeah, escape. This is like, instead of having one CPU with many registers, you have many CPUs with two registers, and one of them is only like, one of them is like a fake register, so this is it's not ideal. So yeah, we do want a JLZ. Less than 0, I guess. L0. So if it's less than 0, we're gonna negate it move ACC down. Otherwise, we're gonna move ACC down. Take the ABS val. And now down here in this node, we'll do the logic. We'll look at how big that absolute difference is now, I guess. Oh. We need to jump start here. Hey, Critical. It's an assembly language puzzle game. So this is like coding, but in puzzle game form, I guess. Okay, so we need to move up into ACC. If it's greater than 0, yeah, we're already ready to go. It's like coding, but in the 80s, yeah. No. This is assembly language is C++ and Python are both pretty like high level languages. Assembly language is nearly as low level as you can get. There's only one level lower, which is machine code, as far as I know. And so it's like you're telling the CPU directly what to do. And it's a little bit hard to describe, I guess. But yeah, you have like registers, which are your memory. You have to move things. Like you have this one primary register where all your arithmetic happens, and you move things around. It's like COBOL. Move up into ACC. If this thing is greater than 0, we go down to true. We move a 1 down. We don't need to do this. If we're not greater than 0, we move a 0 down, and we don't need to do this. Does this work? Nope. It failed on the very first one. Sub 9. Move it to the right. So we have the -9 right here. We negate it. We move it down. We take it here. How did we get 9, by the way? Oh, yeah, because I subtracted the 9. Okay. Oh, I just got my instructions mixed up. No, did I? If it changed by 10 or more... Wait, what? Changed by 10 or more. We do 0 minus 0, we get 0. The issue is this 9 that's getting subtracted. I'm not doing that right, I guess? So... We got to do some math here. It's not as bad as brain fuck. Oh, I have heard of that. Yeah. We're interested in cases where the new x value minus the old x value absolute value is greater than or equal to 10. Yeah, it's just like an intentionally hard programming language. Yeah. So x2 minus x1 can either be greater than 10 or less than or equal to negative 10. White space? Oh no, is it all white space hard locked? It's all tabs and spaces. Inline feeds. Oh, good. Yes, you have some variety. Oh, that's terrible. That's how you do hello world in white space, dude. Oh my god. Yeah. That's the worst one I've heard of. That's worse than brainfuck. Uh if x2 is greater than x1, we're interested if in that, or if x1 is less than x2. Wait, I have that reversed. No? I have this last one reversed. So that's the next one. We want x2 minus x1 less than or equal to negative 10, right? Write an AI script to do that for me. Code for, oh yeah. You want to code a script in an easier language to transform everything you code into white space when you get fired? Oh god, that'd be hilarious. So maybe my issue is that we're sometimes adding 10 and sometimes subtracting 10, right? And so I guess it's a little bit more direct if we use strict inequalities to match um, the constraint of the language. It's a minimalist language that is designed to be extremely simple and easy to learn. Use a teaching tool or a thought experiment to explore the boundaries of what is possible in programming. Thank God that's not what I was taught. That has to be like ironically written or something. So wait, what exactly is the issue with what we're doing? If we have a difference of zero, like is this zero just a special case? Or like if we have two equal numbers, we should always return zero. It's a subtracting 9 thing that's messing it up. Adding 9 wouldn't help it though. You don't like LLMs for coding? Check. Yeah, I personally don't like relying on AI for much anything. Generation of models. Sure. I gotta use the bathroom. There's something civil that I'm messing up here that I can't quite figure out, but I'll be back in a minute. Okay, we're back. Our bladder is empty. That's all we need to know, or that's all we need to be prepared for this mess. Why is it not as simple as subtracting 9 from whatever my difference is between the two numbers? Like, why is this not working? Hey, Lightning. It's an assembly language puzzle game, so it's like coding, but in puzzle form. And it's not even code like Java or Python or C++. This is assembly language, which is a very different type of language. It's very tedious to do anything, but it's been fun to play so far. Yeah, I'm hacking the Pentagon. Coding for masochists, yeah. And now there's like some simple math that I just cannot figure out for the life of me. All the flashy lights and sounds. They're part of it. Oh, is that website still up? Hacker Typer. It is. I'm gonna hack into the Pentagon. Look at me go. I keep on doing the wrong thing. And be like that one TV show where they had two people on the keyboard at the same time just so they could hack faster. Oh, do we want to take the difference, absolute value it, then subtract 9? Okay. I think that's the issue. And if it's still greater than 0, then we change by more than 10. Oh my god, I even beat Jed! I beat Jed! I said the number of lines. Oh my god. Or the number of cycles. Dude, oh my god. The simple math is the hardest math, apparently. He can hack you back in time? Is that an actual superhero? Oh my god. How are these two already not nominal? It's a sandbox. I guess that's why. Okay. It's good. We gotta get our lore. Half an hour so you can watch Kung Fury on YouTube. It's an 80. Oh, really? I've heard of Kung Fury. I never watched it, though. My sister was over for the holidays, I think to check on me. Make sure I haven't gone off the deep end. I know I caused some worry. Her kids saw me working here. Surf the web for TIS-100 specs. The internet is a racket. Like with the information superhighway, and I never will. Ugh. Read from N1 through N4. Write the input number when the value goes from 0 to 1. Two interrupts will never change in the same input cycle. Wait, what? I don't get that third bullet point. Write the input number when the value goes from 0 to 1. I can do that. I don't get the two interrupts thing. I think because maybe they're talking about like in this line down here where there's... Wait, what? The same exact input produces two different outputs? These two lines here are very confusing to... Wait. Yeah. In this one, it changes from 0 to 1 on 3. The next one, it does the same thing, but we output as 0? What? And down here, it changes from 0 to 1 on 4, but it's still 0. How is 0 a possible output? It must be two interrupts will never change in the same input cycle. Two interrupts will never change in the same input cycle. Two interrupts will never change in the same input cycle. What does that mean? Oh, wait, no. I almost had an idea. that we don't start counting new zero or like 1, 2, 3, 4s until we use each of them once, but that's not right because we do a second 3 before we ever get our first 2. Two interrupts will never change in the same input cycle. I don't know what that means still. I'm going to Google this. There's no way I'm the only person with this question, right? More of a hint than a requirement? I don't know what this means, though. Oh, wait. Is it? We're considering the previous line as well in each of these lines. So from this line, I'm I am still not completely sure, but if we in this line we had all 4 zeros, then the fourth 0 changed to a 1, so we output 4. Then in the next line, this fourth one is still the same 1, but now the third one changed to be a 0 or a 1. And then in the next line, there's no change from the previous line. And then in this line, it did change, but we only care about from 0 to 1. And then, okay. Huh. Okay, so each of these needs to independently uh, track itself. Um, level is level and not level. So they all start off with zeros. So we could like move up ACC if it's greater than 0. Jump start. If it's greater than 0, we're going to well, we need to check what's already in there, right? Like we need to see if there's a change. We need like some nested ifs, I guess. So we're moving into ACC. And if this thing is 1, we're going to do a little swap. And if we're greater than 0 again, G0 new, G0 old, G0 old. I think we're just going to jump start. Or, well, actually, we don't need to jump start. But if we can get past this... So, okay. Wait. Okay, if we had a 1, we're going to check what we had before. If it was already 1 before, we're just going to go back to the start. If we didn't have a 1 before, that means we just had a change. So we're going to move 1 down. Okay. But if we have a 0, like we're just... oops. If we get a 0, then we can just swap and we're good. Because we don't care about changing to a 0. Or move up, right, move any, which I need to remember to use, right, move any. Oh, well, okay, the 4th one's gonna have to be special so we can handle the 0 case, I guess. I think this is a template, though. For the 4th one, we do need to output something. Like, we do need a 0 if nothing changed. And how do we do that? And we also need to handle... There's going to be too many inputs at the same time as well. So it's... This second row is going to have to change. Okay, and that's where the hint comes in, which is we're never going to have 2 changes at the same time. So that's going to simplify the code. That's going to simplify like the handling. As soon as we find 1 change. Well, actually, okay, yeah. So that's we don't need to do that much checking then, since our input is up to a certain standard. So actually, that means none of these will ever output a 1, 2, or... Yeah, so we can actually keep it simple. No, we can't. I think they always need to move something. Move 0 down. I want them to specifically push a 0 if there's no change, I think. Um, um, move up into AC, or sorry, well, I get, it doesn't matter. Move left ACC. Change. JGZ change. So if we're getting a 1 or a 2 from the left, we're going to jump down here to change, in which case we're just going to pass along the number. Move left ACC to get the other input. Move JGZ change. Move up ACC, JGZ. Nope. Why did I put a comma there? I wonder why it didn't give me an error. Move right ACC, JGZ change. Start. Jump. Ooh, 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 ooh. And if we don't get any change, we move 0 down. Dang. We were doing well. Is it blocking right now, or what's the issue? Oh, well, no. Welcome back. Yeah, what is the issue? We are blocking. Because we're waiting for left. I mean, could I think even less hard and say move any 4 times? Because I don't actually care. What order these things come in, I guess. No, I can't do any. What order is it receiving? It's first getting from up top. It's first getting from 3, then from 2. Then from 4. 3, 2, 4, 1. So that one is up. That one is left. That one is right. That one is left. And hopefully that forces this thing to be more in sync. Ugh, it doesn't. It does not. They're getting on different cycles. Like, one of these inputs is moving way farther ahead of the others, I think. How can I force these to stay in sync, I guess? Um, this is kind of stupid. Could I move 0 right? Move right nil, move 0, or move 0 right, but I should move left nil. Like, would that force these to wait for each other to catch up? No, it's just blocking. If I change these back to any, I can make that one a lot simpler if this actually works. I can just do one any, but let's not. It's out of sync again. Fuck. It's out of sync and blocking. Well, I guess they're related issues. Can this be move any right? It's blocking west, but it's still out of sync. Where is it blocking now? They're all trying to get input? What's wrong with that? Like, how are these stuck here? I don't get it. I guess 1 isn't waiting for 4 is maybe the issue. I don't know. Okay, so how does this work, dude? Like, I have the idea. It's just this annoying parallel processing. That's the issue. I didn't realize this game would be so much about parallel processing, to be honest. That makes it like I said, a whole new dimension of why it's hard. Um, like I'm wondering about some kind of system where if I get where like instead of passing things down and to the right, I pass things to the right just through that top row as a way of trying to force things to happen at the same time. How would that work? Maybe we should we go into a fresh program for that? Because it feels like an entirely new organization for my ideas, so I don't necessarily want to lose what I had. Ah, who cares? So instead of moving a 0 down or a 1 down, let's move a 0 right or a 1 right. Okay. So if we've already gone, there's a change. JGZ. Name that to 2. Move ACC right. What the heck? JZE, no change. And if there is no change, then we're moving it to the right. And we're jumping start. And then we go back to our old logic. Or, yeah. Okay, this feels like something. It definitely doesn't feel like nothing. So can I paste this all the way over here? I need to move up nil if I need to throw out the input. Um, buy myself another line. In both cases. Well, no, only in one case. I want to throw out the input. Move ACC right. Move up nil. I think right there. We're... What? How is this out of sync? What is happening? Okay, good. So 2, 3, and 4 are all waiting. We find there's no change in 1, so we move a 0 to the right. This thing finds there's no change, so it starts doing its own thing. Meanwhile, 1 is starting on the next input. And that's okay, because it'll hopefully block here. Moving a 0 to the right. Do I need to send a signal back from right to left? That do I need to program some? Oh my god! Oh wait, you know what? It doesn't. It doesn't help that I'm not routing the output anywhere. It still blocks, but at least it has a. Oh, I forgot to change that. Probably not helping either. How is it? How does 1 get stuck? Hey Brian. Yeah, this is a game. It definitely exists. That is so weird to me how the first input somehow never progresses past the first. Like, is it now? Is 1 for everyone stuck on move 0 right? No. Now is 1 move forever stuck on move 0 right? How? Wait, I'm never reading. Oh, I forgot to move up into ACC. That seems like a really important step. Okay. So, um, I don't know. I feel like one has to block until two is ready. Again, until two is done. Two has to block until three is done. And four has to. Well, four. Oh, God. This is not easy. Um, why am I so dark in my face cam, by the way? Uh, maybe it helps if I sit up straight. There has to be a better way. Like, can I offload all of this no change scenario to the nodes right below? That seems like it would be helpful. And I don't think it'll be that hard. How do I deal with there not being a change? If one is changed, we know none of these others are going to change. So if there hasn't been a change, then we can just move up, down, and let that do the processing there. Okay. I think it's at least an improvement? Or at least I have more room to play and try to make things sync, I think, is the upshot of this. Um, I need to fix how things are being routed. Like these outputs have to be routed differently now. Oh wait. Um yeah. I don't know how this routing, like this node being blocked is really annoying. Can you are you able to fix these? I wonder. It's not obvious to me how you would, I guess. I don't know why debug just gives you this message. But like dealing with this one input is kind of the issue. I'd love to have just a third level to move things around with. Let's see, let me check my phone. Oh, okay. Man, this one is. What is this one? How do I keep these nodes in sync? Because I don't think this transferring half this code to the bottom row or to the middle row actually helped. I so okay. Well, I think we'll go back to moving things down onto the second row, whatever our results are. This one can be special. It can also use addition to not have to think too hard about which one I send. So we're guaranteed that only one of these interrupts changes at a time. So we can safely just add the two because the other one will always be 0. If we get if JGZ for greater than 0, change. Oh, no, 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 we can't do like this. Well, we can. We need 4 of these, though, unfortunately. I thought we could avoid it, but we can't. Move 0 down. Sorry, not move, mob. Otherwise, move 1 down. And S. Those are not going to work. Yeah. It fails on the first try, even. Why would that be? We should probably... What's sending a 1 when it shouldn't? Oh. I didn't change these things. Okay, well, let's get past the first line. You know, that's progress. 702 is lagging behind. That's kind of funny. I think because of this bottleneck here. It's probably better to... Well, no. How quickly did we make a mistake? In the second line now. But things just aren't running in sync, so I, like... The synchronization is still my issue. It's getting harder to think. I'm trying to figure out some kind of way that we can pass things left to right and then back again. We could even use this, like, second row here, potentially, to help with that. So I'm thinking, which is dangerous when I think, but I am thinking that Uh, can we move, like, I want something like move down nil, and this node down here. Its first instruction can be moving whatever we want up. But then it needs to take a signal from the right nil. So it can also move 0 up. Take an instruction from the right nil. Well, yeah. And then once it's had the instruction from the right, it can move left whatever we want. This is complete like instinct right now. I don't know if it's actually good. Move, oops, 0 left. Move 0 up. Move left 0, wait. Yeah. Ah, move 0 left. Move 0 up. We take the signal from the right. We send a signal to the left. And now these all need to wait. Move down nil. Move down nil. Move down nil. Move down nil. Does this force us to be in sync? It sure doesn't. So they'll get their zeros. They all pull their first inputs. And then this signal to pull the next one is already going, which maybe that's the issue. Maybe I needed to change up that order. Yeah, that makes more sense, I think. And this one, we would move 0 left at the very end, but then huh. Can we make that our first instruction instead? And then move right nil. Move 0 left. This thing needs to wait for the right before it does anything. I hope I'm not just reading this into the same order I just had it in. And then once it's able to do something, it'll tell the thing above to do something, and then it'll tell the thing to the left to do something. This thing is going to wait for the right to tell it to do something. Tell the thing above it to do something, and then tell the left to do something. This thing will wait for the right to do something. Wait, oops. Dude. Why do you have two move down nils up there? This is so hard to like. I don't know what I don't know what I'm doing. Um, I don't know. My brain doesn't work anymore. I think I need to call it because this one is so hard. Four different inputs, and each one is just like flying off at their own pace. I might have just happened to get lucky if like maybe this little bottleneck here didn't exist with that one being blocked, but even then, no, that still just goes collapsing four things into one thing. Uh, there's clearly something here that I'm missing, but I don't think I'm gonna get it anytime soon. So yeah, I think let's call things there for the day.